Okay, so obviously today you have a sub. I'll be gone for the rest of the week in Boston. Um, so we're going to see how long this slide is. This slideshow, I should say, is. If it's, if it's really long, then maybe we'll break this up into two. So you can do part today and then part of this on, let's see, Tuesday, so Thursday in class. Or maybe I'll have another slideshow for you on Thursday. It really depends on how much time this takes, and I won't know until I finish this first recording. So I'll let you know at the end of the recording what I think, if we should break it up into two or if I'm going to have another slideshow. Okay, also, this is more for the sub and for you guys. I think Charlotte, you had asked me if it would be okay if you guys did it on your own on the phone, and that's certainly fine with me. It's up to the sub, but if you are doing that, then you need to be making sure that you are using your phone only to watch this, and that way you can start it and stop it at your own pace. You certainly shouldn't be playing on your phones and doing something else. Okay? Also, you guys are allowed to use a calculator for this, and you know where they are. I'll have them out. Just make sure you put them back. Okay? Alright, so let's go ahead and get started. So, we're always going to solve for radians unless it says otherwise. For the most part, from here on out, we're going to be doing radians and not degrees. And then, we reviewed this before, or we've done problems like this, where we find the angle that gives us, like for instance, if we had this, so this is just a recap for us. If we did, say, when does the sine of theta equal 1/2? Well, we've already done problems like that, and we're going to be doing more problems like that today. They're a little different, so we're going to put a little different twist on it than what we've discussed before. But clearly, the sine of theta equals 1/2. Remember, if you remember your 30, 60, 90, well, 1/2 is going to happen in your 30, 60, 90. So in 30, this would be 1, this is 2, and root 3. So sine would be 30 at 1/2. Okay, so for numbers like 1/2 or anything with root 3, anything with a 2 or a 1, we're really going to be looking at 30, 60, 90. If there's, or a 45, 45, 90. And I should include root 2's in that list. Okay? But when I'm looking for sine, cosine, secant, and, oh, this should say cosecant, that's a mistake. Cosecant equaling 0, 1, or -1. You're going to want to look at the graphs. You're not going to want to draw the triangles so much. The graphs are a better tool. Okay, so for instance, sine and cosine only equal 1 or 0 at here when it falls on an axis, and that's a little harder to figure out what the values are at those points. You certainly can do it, but since we're already really good at graphing, I think that we should really look more at the graphs of these things when we're looking for 0 and 1 than drawing this picture. But either way would really work. But I do want to be careful. Tangent doesn't equal 1 on the axes. So sine and cosine equals 1 on the axes and 0 on the axes. But tangent equals 1 in a 45, 45, 90, not on an axis. So you're going to look at a 45, 45, 90 triangle for that. And so for tangent equaling 0, you're going to look at the graph, but for tangent or cotangent equaling 1 or -1, you're going to look at the 45, 45, 90. So I just want to make that clear. Okay. So we're going to go on to the next slide. Okay, so we're looking at this graph. This is a sine graph. Pretty good at that. I want to know when does sine theta equal 0 over the entire number system and also over the interval 0 to 2 pi. So for all of these questions, we're going to be looking at over the whole number system and then over the interval 0 to 2 pi. And I want you to notice this is a closed interval 2 pi, where before we were looking, I think, to 4 pi, and we were looking at an open interval. This is a closed, so we do want to get 2 pi in our answers, but we don't want to go past 2 pi. Okay, so when does sine equal 0? Well, it equals 0 here, 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 and here, right? So over the entire real number system, we would say what? What have we been saying? We've been saying at the whole pi's, right? And that's not really a very good mathematical term, but it's what we've been discussing, so that's fine for now, and then we're going to clean that up a bit in a minute. Okay, now over the interval 0 to 2 pi, so over the interval, over the interval 0 to 2 pi, it is 0 at 0, pi, and 2 pi. Okay? So next slide. So let's look at cosine x, and I'm going to grab a new color because this is a different color graph. It's a red graph. So when does cosine theta equal 0 over the entire real number system and over the interval 0 to 2 pi? Well, for the entire real number system, it looks like it's happening at these half pi's. So again, this is not a very good mathematical definition, but we've been saying, or terminology, we've been saying at the half pi's, right? And again, we're going to clean that up in a little bit, but for right now it's at the half pi's. And then for the interval 0 to 2 pi, and remember 0 to 2 pi is from here, this is 0 to 2 pi, so right here, and it does include 0 and 2 pi, so it's 0 here and here. So since this is pi, this must be pi over 2, and this must be pi over 2, 2 pi over 2, so this must be 3 pi over 2. So my two answers for just over the interval 0 to 2 pi is pi over 2 and 3 pi over 2. So nice job. Okay, so moving on. Let's look at sine again. And this time we want to know when does sine theta equal 1 over the entire real number system and also over the interval 0 to 2 pi. Okay, well, it equals 1 at these points. And I'm going to go back to a different color. So I think we liked why is the colors not coming up? Sorry about that. That was weird. Okay. It looks like it's 1 for the whole number systems. It's here, and here, and here, and here. Now we have been saying that it's equaling 1 at the over 2's, but what we really say it equals 1 and negative 1 at alternating over 2's, right? So it's 1 and negative 1 at alternating over 2's. And then I asked, how is this different than when it equals 0? And really, the problem with this is the alternating issue, that it isn't at every pi over 2 that it's at 1, it's only at every other one. And so that's what we're going to have to clean up, and we're going to get to that in just a minute. So really, it's the difference here is the every other one. Pi over 2. Alright, so it's at every other pi over 2 instead of every pi over 2, versus on 0, it was when we were looking at 0, sine of 0 at every single whole pi. Okay, and then also just over the interval 0 to 2 pi, so again, the interval 0 to 2 pi is right here. Here's 0 and here's 2 pi, so it only equals 1 one time in here, so the answer would just be pi for on the interval 0 to 2 pi. And that in itself is different. It equals 0 3 times, but it only equals pi once, right, on the same interval. Okay, so next slide. Go with the again. Okay, so again, this is the same issue that we ran into with sine. When does it equal 1? Okay, well, we said at the whole pies, when we were just talking about it, we said again 1 and negative 1 at the whole pies. When we were just learning to graph, we said it was 1 and negative 1 at the whole pies. I guess we said 1 or negative 1 at the whole pies, and then we said it was 0 at the halves. Okay, that's still true, but again, the difference here is the alternating, right? It's 0 at every single pi over 2, sort of. But it's not 0 at every single pi, or it's not 1 at every single pi. It's either 1 or negative 1 at every single whole pi. So again, it equals 1 here, and then again here, and then again here, and we need to say where it's going to go forever, and then also over the interval 0 to 2 pi, and again over the interval 0 to 2 pi, it's going to be at 0 and at 2 pi. Okay, so this is really kind of just a recapping, and now we're going to get to the meat of the problem. So here we go. For all of these slides and in the book, it's going to be asking for two things. It's going to be asking for what's happening over the whole real system, and also over just the interval 0 to 2 pi. So 0 to 2 pi is a finite set, so that means we're going to have a finite amount of answers. There's going to be a specific amount of times, right? But if we're looking over the entire real system, we're looking for an infinite amount, and so we have to come up with a better, more mathematical terminology for expressing all of those solutions, so that if I told someone who really knew not that much about pre-calculus or trig, that they would know when we would get these solutions all the time. Okay, so here we go. I think the darker blue is better. You know, I think I might go with purple, because most of my slides aren't in purple, and then I don't have to switch back and forth so much. Okay, so here we go. Moving on. Okay, so now we're going to talk about how we can write this in a better, more mathematical way. So let's just look at this again. Remember, it's 0 here, and here, and here, and here, and here, and here, and here, right? And So I listed these here. So negative 2 pi, negative pi, 0 pi, pi, and 2 pi. Remember 0 pi I could just also write as 0. So those dots mean generally that 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, blah 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 are covered. And then before that, negative 3 pi, negative 4 pi, negative 5 pi, negative 6 pi. So writing it this way is better than just saying it the whole pies, but it's really not the most explicit way. Okay, so let's just talk about this. It looks like it's happening at every multiple of pi. So every, not multiple of pi, because not every multiple of pi, because like a half pi isn't right? So it looks like every whole number multiple of pi, or every integer multiple of pi. So the way that we're going to write this is we're going to say that sine theta equals 0 at 0, because that's the first one that we find, plus pi times some number n, where n is an integer. And we've said now that n is an integer, and I'm not going to keep writing that. N is typically understood to be an integer. Okay? Now, what is 0 plus pi n? Well, 0 plus pi n is just pi n. So let's see if we think that this works. When n equals 0, I get 0 times pi, which is 0. That's one of them. When n is 1, I get pi. When n is 2, I get 2 pi. When n is 12, I get 12 pi. When n is negative 1, I get negative pi. When n is negative 2, I get negative 2 pi. So it looks like I'm getting all of them. So basically, sine of theta is 0 at every pi n, where n is some integer. Okay, so that's a really tight mathematical definition. You don't really need to know that much about trig, as long as you know that n is an integer. You know this thing's going to be 0 at any number that's a whole number times n. Okay? Let's look at the next slide. Okay, but this is where it gets tricky. So here, it's 1 at the half pies, but not every half pi. Okay, so it's 1 at the half pies, but not every half pi. It's actually every other half pi. So here and here, but we're skipping this half pi right here. Okay, so saying it as a half pi is really super inefficient, because we're really not clear where we should start and all of that. So we're going to come up with a better way of writing it. Okay, so we're going to look at the first positive one. It really doesn't matter where you start, but typically you start at the first positive time that it equals 1. So that would be at this point here. And this point here is pi over 2. So I'm going to say pi over 2 plus, now, how long until it repeats itself? Well, let's talk about this. What is the distance between here and here? So just think about that for a minute. Okay, so we're looking for the distance between these two lines. So it's the first time that it's 1 is right here. And then it's 1 again right here. So how long is it from here to here? Well, let's count. Each of these marks in here, each of these represent a pi over 2, right? So this would be pi over 2. That would be a length of pi over 2. This would be a length of pi over 2. This would be pi over 2. And this would be pi over 2. So if I add these up, it's pi over 2, 1 pi over 2, plus another pi over 2 would be 2 pi over 2, plus another pi over 2 is 3 pi over 2, plus another pi over 2 is 4 pi over 2. And 4 pi over 2 is 2 pi. So it looks like it repeats itself every 2 pi times, right? And let's check over here. From here to here, again, the distance is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And here, same thing, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So it looks like it repeats itself every 2 pi times. So in this one, it's going to be plus, it's going to be at the first one, which is pi over 2, plus every 2 pi n, where again n is an integer. So it's repeating itself every 2 pi times. Okay? So I want to go back a slide so I can show you the difference. Okay? So this repeats itself every 2 pi times. So we have to talk about the first one. We can't say just 2 pi n. I'm going to go back in just a second. We can't say 2 pi n because when n equals 0, we're saying, okay, so 0 is the solution. Well, it's not 1 at 0. It's not 1 until pi over 2. So we have to start with one of them, and then we can say plus or minus 2 pi n. And typically, we start with the first positive time that it equals 1, which in this case is pi over 2, and then we add the 2 pi n. Okay? Okay, so let's go back a slide. So that would be this way. Would we go back and slide? Now this says pi n, where the second slide, remember, said 2 pi n. So it equals 0 at every pi n, but it equals 1 at pi over 2 plus 2 pi n. So how come this is pi n, or plus pi n, and this is plus 2 pi n? Well, if you look at this, this repeats itself every, it's 0 just over these two, a distance of 2 of these units, right? And each of these units is pi over 2, so pi over 2 plus pi over 2 is 2 pi over 2, which is pi. So this repeats itself every pi, where, so it's 0 every pi time, okay, sorry, I was having a clicker issue. Okay, so let's go back to this next slide. So here we go, here's the next slide. Again, it's only 1 every 2 pi times instead of every interval of pi. Okay, so that's why we did 2 pi n. So we sort of have to look at that and decide, we're going to have to decide that in our solutions. And so the solutions get harder. So also deciding if it's 2 pi n or pi n is a little more difficult. And we'll go over that as we go along. Okay, so the next slide. Okay, so let's look at cosine. Remember, cosine is 0 at the half pies, pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, negative pi over 2. So that's when it equals 0. So let's talk about it though. So it equals 0 here, and here, and here, and here, and here, and here, and here, right? It equals 0 at all of those, right? Okay, and what is the distance? What is this interval? It looks like 1 pi over 2, that's 1 pi over 2, and this is 2 pi over 2, so it looks like a 2 pi over 2 or pi. So this looks like it repeats itself every pi time, right? So instead of plus 2 pi n, we're going to have a plus pi n. Now, when is the first time that it's 0? Well, it's not 0 here. It's not 0 right here at 0. It's 0 for the first time right here, right? And that point is pi over 2. So I'm going to say at pi over 2 plus pi n. So I know that cosine is 0 at every pi over 2 plus pi n. And then let's just plug in some numbers to check. So when n equals 0, I get pi over 2 plus 0, which is pi over 2. That looks good. When n is 1, I get pi over 2 plus pi times 1. And pi times 1 is just 1. So I have pi over 2 plus pi. And if I change this to pi over 2 plus pi is 2 pi over 2, then I get 3 pi over 2, right? And we said 3 pi over 2 is the next answer. And if I did n equals 2, I'd have pi over 2 plus 2 pi, right? And 2 pi, written as 2 pi as an over 2, would be 4 pi over 2. So 4 pi over 2 plus pi over 2 would be the next one, which is 5 pi over 2. And then if n was negative 1, I get this negative pi over 2. So this looks like it's a good answer. And again, when you write this answer, you should check. You should look at your graph, go ahead and graph it, and check it. Okay? All right. So for this, you're just looking at a graph. You're just checking it by looking at the graph. That's fine. Okay. And these ones, it's easy because it falls, you know, here at one of these nice values, right? This all changes when instead of equaling 0 or 1, it's going to equal a half or a third, right? So a little more work. We're not just going to have to look at the graph, then we're going to have to do a little more work. And that's coming, but I wanted to make sure you understood this part first. Okay, so next slide. So why don't you try this one on your own? So I'm going to ask that the sub pause this and let you guys try this on your own, and then we'll come and recap in just a second. But I'm not going to wait. I'm going to say the sub should pause, and then I'm going to keep going. So then you'll restart me and I'll be started right back up again. Okay, so you've paused and now you've restarted. So we want to know, when does this equal 1? Okay, so again, it equals 1, he said, at the whole pies, right? But it's not every whole pi, because at pi, it's actually negative 1, right? So it looks like it's these. So again, we have to talk about how often that repeats. So we need to know what this distance is here. So this distance is, any guesses? It looks like 2 pi, right? So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi. So that distance is 2 pi. So it looks like it repeats itself every 2 pi times. So we're going to say that it's going to be plus 2 pi n, where again n is some integer. I'm going to quit writing that, but yes, n is some integer. And we have to talk about what the first time it is. So the first time it happens is right here. This is the first time, and that's at when my x or theta is 0. So it's right here when it's 0. So that my first solution is 0 plus 2 pi n. But 0 plus 2 pi n is just 2 pi n. So I don't need to write 0 plus 2 pi n. I can just write 2 pi n for n being some integer. Now I wouldn't mark you wrong for writing 0 plus 2 pi n. Okay? Next. Okay. Oops, there we go. Alright. So here's where it gets a little different at a half. So let's look at a half. This is 0 and this is 1. So a half looks to be about right here. And you know, I'm drawing on this, so you have to excuse that my line is not all that straight. But it roughly looks like this, right? Okay, so first of all, on just 0 to 2 pi, and I'm going to grab a different color for this one. I'm going to go with the red. From 0 to 2 pi, it looks like it's happening a lot. It's happening here, and it's happening here, right? So it's only happening twice on the interval 0 to 2 pi, okay? And then again, it's happening here and here. Outside of that interval, and then again here and here, and then here, and there's going to be one over there too. So the thing is, I could figure out what this interval is, right? I could figure out what that interval is. I'm not going to, but I could figure it out, right? So it happens here and here, but then this spacing is certainly going to be a different spacing than this one, right? This interval, that was really kind of terrible. Let me see if I can get the eraser and try that again. Okay, this interval is certainly much shorter than from here to here, right? From here to here is certainly much shorter than from here to here. So it's not going to be every pi n or 2 pi n times. It looks like what's really happening, and this is kind of a key point that you need to see here, is that this first one, let's look at the first time. So let's do this in a totally different color. Let's go with this green. Okay, here's this first one. Okay, and then it hits this first one again right here. Okay, so this green distance is actually going to end up being a distance of 2 pi. So it hits the first one, and then 2 pi later it happens the first one in the second pairing, right? So we're going to actually have two answers to this. We're going to have some number, whatever this is, plus 2 pi n, and then we're going to have this solution. Let's do this in another color, like maybe, I don't know, maybe this orangey color. I don't know how good it's going to show up. But then we're going to have this one, and then we're going to pick up the second pairing over here. and that's going to be something plus 2 pi n. So for both of these, we're going to have this. And if you're getting confused, I'm sorry, but it'll make more sense when we actually do one. We're going to have my first answer, which is whatever this point is, so whatever that is, plus 2 pi n. And then we're going to have this answer, so whatever this point is, plus 2 pi n. Because we can't combine it into just one, because it has these two. The spacing from here to here is certainly equal to the spacing from here to here, but the spacing from here to here is not the same as from here to here, or here to here. So that's an issue for us. That's why we need to have two equations to represent both sets of solutions. Okay, so we're going to go ahead and solve this one next. So I think it's next, but we'll see, and we'll get to it. And I'm going to, I think, call it the green slide color and go to the next slide. Yep, so here it is. Okay, so here's how we come about the numbers. Since looking at the graph is hard to tell exactly what that point where it's equal to half the first time is, we have this other way of looking at it. So we remember that sine is opposite over the hypotenuse. Okay, so, and we know that sine is positive, so I have this little key for me to remember. The sine is positive in quadrants 1 and 2. Okay, so 1 and 2. Okay, so I'm going to just go ahead and draw this point 1 over 2. Or, I'm sorry, I'm going to draw a triangle in the first quadrant. And I'm going to say that this is 1 because the opposite side is 1. And the hypotenuse is 2, so this has to be root 3. Now this is theta. This angle right in here is theta. Okay, now our job is to figure out what theta is. Well, theta is across from a 1. So in a 30, 60, 90, what angle is across from 1? And yes, you should all be saying pi over 6. Okay, I guess I'll go ahead and keep that. So we know that theta is pi over 6. Pi over 6. So it's pi over 6. Now that's the first time, okay? Then it's again over here in quadrant 2. So again, this is pi over 6. And this is 1, 2, root 3. Okay, but this time I want to know what this angle is from here to here. Well, since we're talking pi over 6, this is 0, and this, remember, is 6 pi over 6. So it looks like we're pi over 6 short of actually achieving 6 pi over 6. So that would be 5 pi over 6. So my answers are theta equals pi over 6 plus 2 pi n, and theta equals 5 pi over 6 plus 2 pi n. Okay? Now let me show you why we're going to just go with the two solutions. So the two solution rule really happens when these are not a full pi away from each other. If they're less or more than a full pi away from each other, then we can't just say plus 2 pi n. So what's happening is, if you just look at this, it's reaching a half in the first and second quadrants, and then we have this long jump where we don't have a solution in the third and the fourth quadrants, and then it starts up again here in the first and the second, and then nothing, and then in the first and the second, as I keep going around the first and the second, and then nothing, the first and the second, and then nothing, right? So I have these pair that are close together, but they're not pi apart or 2 pi apart. There's some other number pi apart. They're actually, what's 5 pi over 6? Pi over 6 and 5 pi over 6 is this interval, so it's between the interval here on the, I think I'll wait and talk about that when I show you the actual graph. Okay, so just scratch that for a second. Now I want to show you mathematically, and this is always a good thing to check. So first of all, these answers are only the 0 to 2 pi answers. Okay, so these are only the 0 to 2 pi answers. So let's just look at these a second. When n equals 1 here, when n equals 1, I'm going to get 2 pi plus pi over 6. So that would be 12 pi over 6 is how I'd write 2 pi plus another, not 12, yeah, 12 pi over 6 plus another pi over 6 would be 13 pi over 6, which is not this next one, 5 pi over 6. Okay, so that's how you know that you need the two separate ones. That's one way of knowing that you need the two separate ones. Okay, so here we go. Now we also need, where is it happening on just the interval 0 to 2 pi, right? So this is part A, this is over the reals. Now we want to know when it happens at 0 to 2 pi. And it happens here at pi over 6 and 5 pi over 6. And then by the time we get it back to here again, we're repeating, right? But again, you can check that by saying, okay, well when n equals 0, we get pi over 6. And 5 pi over 6, and those both fall in the interval 0 to 2 pi, so that's looking good. But when n is 1, I'm going to get pi over 6 plus 2 pi. Well, 2 pi plus something is going to be over 2 pi, and we have to be between 0 and 2 pi. And a good thing to look at is to change this. Since I know it's going to be a something over 6, 2 pi is really 12 pi over 6. So we know that the answers have to be between 0 and 12 pi over 6. Okay. So part B, the answers are pi over 6 and 5 pi over 6. So that's the only two times that it happens on the interval 0 to 2 pi. And then these answers, part A, are over the whole real number. When does it happen? And that's where it happens. Okay, so let's look at the picture and see if we can clarify some things for you. So here's my cursor, and I need to get back to my tapper. And I've got the arrow. Yeah, I've got the arrow. Okay, so that disappeared because I want the picture to come in. And there it is. And I think that this stuff's sort of in the way, so I'm going to go ahead and erase this stuff. So I think just this stuff is good. So again, here's the graph of sine x from 0 to 2 pi. Okay. Let me get my pen back. Okay, so the distance between here and here, so it equals a half, remember, here and here, roughly. So this distance here, we were talking about what that distance actually might be. And that is at, well, this value right here is pi over 6. And this value right here is 5 pi over 6. So remember, the distance between these would be 5 pi over 6 minus pi over 6, which is 4 pi over 6, which is 2 pi over 3. Okay, so that interval is not pi or 2 pi, so we can't just say plus pi n or plus 2 pi n. So again, just, you know, to beat a dead horse here, we have to say this first value right here, plus, which is pi over 6, plus 2 pi n, because this repeats every 2 pi times. We know that every single value repeats every 2 pi times, because the period is 2 pi. So we know it's going to hit it again about right here. And this distance is definitely going to be 2 pi. And then it's going to hit it, we're off the screen a little bit, off the screen here is going to be 2 pi from here. So we have to say this one, pi over 6 plus 2 pi n, and then 5 pi over 6 plus 2 pi n. Okay? So that's how I know that I need to write it as two separate equations for that. And then over the interval 0 to 2 pi, well, this is the interval 0 to 2 pi. Here's 0, and here's 2 pi. It only happens twice, which we found before, and that's at pi over 6 and 5 pi over 6. So those are my answers. Okay? Now here, if you're using the graphing calculator, which I'm encouraging, you could graph this for yourself so you wouldn't have to look at mine. And then again, you could do the calculate, so you can hit, after you've drawn the graph, you can hit the, I have to look at my calculator so I can tell you. So you do y equals, type in the equation, and then graph it. You're probably going to want to change your interval from 0 to 2 pi, or maybe negative pi over 2 to maybe negative pi to positive 3 pi. So you can plug in numbers at 0 and 2 pi, since we are including those. But you're going to probably change your graph so you can plug in those numbers. But then remember, if you hit second calculate and then value, you can plug in values, and then it'll, when you plug them in, you'll see. So I would plug in pi over 6 as a value, and you'll get a half. And then if you plug in 5 pi over 6, you're going to get a half again. So that's how you know that you've got those two right. Okay? Okay. So let's try another one. Okay, so tan x is negative 1 in the interval 0 to 2 pi, and I gave you this little note earlier about tangent and 1 or negative 1. Remember, that is not on an axis. It's not here, it's not here, 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 or here. Okay, that's true for sine and cosecant and secant being -1, but not for these. Okay, so I'm going to delete those, and we have to do it the other way. Okay, so the other way being, looks like my pen's gone. Okay, now it's back. So the other way is going about it this way. So I know that tangent is opposite over adjacent. Okay, and it's 1 when the opposite and adjacent sides are the same. And again, that happens in 45s. But we're looking for where it's -1. So tangent is positive in quadrant 1. So we're going to look here at quadrant 2. And I'm going to just draw this. And then tangent's positive in quadrant 3. So it's going to be over here. Now, do you see how these are, this distance right here, or that angle right there, is pi. So these are pi apart. And remember the period for tangent is pi. So instead of saying plus 2 pi n, I get to say plus pi n. And I'm not going to probably have 2 solutions, but I'm going to tell you exactly how you can tell when we actually find the first solutions and then talk about it. But over here I'm just going to draw a really quick graph. Remember the first one looked like this. They weren't pi apart. They were much shorter than pi apart, right? And if I looked at this picture, like if I had this one and this one, they'd be, this is over pi apart also. So if they're exactly pi apart, then it's usually just one answer plus pi n. And also with tangent, that's awfully common since tangent is, the period is pi. Okay? So let's get to this. I'm going to delete this. Just this part right here. Okay. Okay, so we know that the opposite and adjacent sides have to be the same. So that looks like 1, 1, and then this would be root 2, and that happens when this is pi over 4. Okay, now this little angle is pi over 4. So this is 0, and this is 4 pi over 4. And this would be 8 pi over 4. And we're looking for the interval 0 to 8 pi over 4. So we don't want answers bigger than that. And then we also want for any real number, right? So for 0 to 2 pi, we're going to get those first. We're going to have this. So that's pi over 4, but what we're really looking for is that, and that's pi over short of 4 pi over 4. So that would be 3 pi over 4. Okay. And then this next one would be, that's pi over 4 again, and again 1, 1, and root 2. And this would be pi over short of 8 pi over 4, so it looks like 7 pi over 4. Okay, so since these are 180 apart, right, since it's 180 apart, I know that if I say plus 2 pi n, I'll definitely get this one again, but I'll be skipping this one, right? So if I say go all the way around from here, then boom, I'll get this guy again, but I'll have skipped this one, right? So I think if I say pi n, I'm going to get this one and this one. Okay, so we're going to double check that. So let's just double check it. We're going to say plus pi n. Okay, and here we're going to say plus pi n, because this is the second one, right? So here we go. When, and we're going to answer the 0 to 2 pi part too. So the 0 to 2 pi part, when n equals 0, I get 3 pi over 4 and 7 pi over 4. Right, when n equals 0, I get 3 pi over 4, and when n equals 0, I get 7 pi over 4, right? But what happens when n is 1? Oops, I didn't mean to do that. Let's put that. Okay. What happens when n is 1? Okay, so let's just look at this first one when n is 1. Then I'm going to get 3 pi over 4 plus pi times n, but n is just going to be 1. Okay, so 3 pi over 4 plus pi, and the best way of writing pi is 4 pi over 4. And what is 3 pi over 4 plus 4 pi over 4? Yes, you guessed it, it's 7 pi over 4. And do you see that 7 pi over 4 was our second solution anyway? So that means we don't need this second solution. So I get to cross this solution out. Okay, so over the reals, the solution would just be 3 pi over 4 plus pi n. And that will get every single one. Okay, so I don't need 2 solutions for this one, I just need 1. And again, you need to be thinking about that when you draw this picture here. You get this straight line action going here, right? Here, I'm not getting any straight line action when I do these 2 hypotenuses, right? Those 2 lines intersect each other, right? And here, again, I'm not getting a straight line, I'm getting more x action going, right? So when I'm getting a straight line, that's usually a clue that the distance is going to be pi n, and you're only going to have to write 1 answer plus pi n instead of 2 answers plus pi n. And I noticed when I was taking this class for the first time, I noticed that that's mostly when it happened. Whoa! Wow. I picked up my computer and something weird happened. Okay, let me get back to where we were. Sorry about that. Ooh, stop doing that. Okay, let's try again. Oh, I know, I was hitting the mouse. That's what I was doing. And it's not the computer so much as the mouse. Okay, now it should be better. Alright. Couldn't find my cursor, sorry about that. Alright, there we go. Up here. No, I don't want that. Actually, I want to go here. Okay, there we go. Nope, next one. Alright, there we are, tangent. Okay, now I'm gonna hit this, and that guy's gonna go away, and here is a picture of tangent, and let's get rid of all this writing right here, so that you can see what's going on. So all this stuff is gone. right? Okay, so let's look at it. We want to know when it's -1. Well, here's -1 right here. -1 is right here, so this is the -1 line, and it looks like it, between 0 and 2 pi, it hits it here and here. And this certainly looks like this is halfway between pi over 2 and pi, so that would be 3 pi over 4. And this looks like it's halfway between 3 pi over 2 and 2 pi, which would be 7 pi over 4, so that's looking good. Okay? Alright. And again, you should check on your calculators. Okay, next slide. Okay, so, oh, why did that stay there? That's really odd that that's there. Here's change, that's scary. Why isn't the eraser working here? Okay, let's go back. Okay, why didn't this erase though? Erase all and you can slide and that one didn't erase. Okay, well we're having some sort of technical issues, so I'm going to have to put you on pause and investigate and start up. Actually, now would be probably a good time to stop. It looks like this has been, well, it depends on what time it is. If there's still a lot of time left in class, then you can keep going. Otherwise, it depends on how many times you've stopped and started this. Otherwise, we can stop it and pick this up next time. So it looks like this is all we're going to have time for is this slide and, I'm sorry, this one slideshow. So we are going to do it over two periods. We're going to do it on Tuesday and Thursday, so I'm not going to have a different slideshow for you. Okay. Okay, so we're definitely going to stop here and I'll restart. Okay. So we'll pick this up on Thursday.